What's up guys, Stephen Gillen here with CertWiz.com, and this is part one of a two-part discussion on describe the impact of infrastructure components in an enterprise network. In this video, we are going to talk about firewalls. We will discuss the core purpose of a firewall, the logic behind how it operates, and its core features. Let's get started. The core purpose of a firewall is to allow or deny traffic flow in and out of a network based on predefined security information. The firewall usually sits in the main forwarding path of all packets so that it can choose which packets to discard and which to allow through the network. Although a firewall has some router-like features such as packet forwarding and filtering, the firewall provides much more advanced security than a traditional router. Now, don't worry, we will talk about router-based security a little bit in later videos. Most firewalls like the Cisco ASA or Adaptive Security Appliance uses the following logic to determine if a packet should be allowed or discarded. A firewall can use an access list or ACL to make a variety of filtering decisions. Think of an access list as you would a VIP list at a nightclub. You have a bouncer that stands at the entrance looking at this list to decide who to allow in. With the ACL or access list, a firewall can match source and destination IP addresses, identify applications by matching their static well-known TCP and UDP ports, watch application flow for unique TCP and UDP ports, and match the text in the URI of an HTTP request and make filtering decisions based on this information. Now, let's talk about one of the core features that defines a Cisco firewall, and that is stateful filtering. With stateful filtering, a firewall is able to store information about each packet and make decisions about filtering future packets based on the stored state information. This process is called stateful inspection or being a stateful firewall. Now, firewalls not only filter packets, but they can also pay attention to the hosts that initiate communication and permit or deny that communication based off the host location. To fully understand this, let's talk about the security zone feature of a firewall. Security zones on a firewall are used to determine which areas of a network should be trusted and which areas should not. There are three defined zones you should be aware of, and these are inside, outside, and DMZ. Let's take a look at an example. We will focus on the inside and outside zones for now, then talk about the DMZ. The inside zone is usually your local area network or LAN and is considered the most trusted by default. Hosts located in the inside can initiate communication or connections to the DMZ and outside zones. And because of stateful filtering, the firewall can remember the source and destination ports of a session and dynamically allow return traffic back into the network to that host. The outside zone is considered the least secure part of the network, and by default, a connection cannot be initiated from an outside zone to a host on the inside. Now, before we discuss the DMZ, let's talk about another important concept, which is security levels. When assigning security zones on a firewall, a security level has to be assigned as well. These security levels determine how secure a particular zone is. By default, a host device located in a more secure zone can initiate connections to a least secure zone. And a host device located in a lower level zone or least secure zone cannot initiate connections to a higher level zone. In our example, we are using security levels 100 for the inside, 50 for the DMZ, and 0 for the outside zone. I know what you guys may be saying right now. What is he talking about? So let's think of it like this. We have a 3-level waterfall, right? The top of the waterfall is the inside of your network with a security level of 100. The DMZ is the mid-level on the waterfall, with a security level of 50. And the outside zone is the lowest level on the waterfall with a security level of 0. Now, looking at our waterfall and thinking of our connections as water flow, can the inside zone with a security level of 100 flow or connect to the DMZ with a level of 50? Yes. Can the inside zone flow or connect to the outside zone with a level of 0? Yes. Keep in mind, zones with higher security levels by default can initiate connections with zones with lower security levels. So, continuing with our example, looking at the DMZ with a level of 50, can the DMZ with level 50 flow or connect to the outside zone with a level of 0? Yes. But can the DMZ flow up or connect to the inside zone? No. Looking at the outside zone with a level of 0 and at the bottom of our waterfall, can the outside zone flow or connect to the DMZ or the inside? No. Why? Because water flows down a waterfall, not up. Right? So this was a pretty cool way I remember how security levels and zones work on a firewall. Now, looking at our example, you may be telling yourself, okay, Steven, I get the concept now. But wouldn't we want hosts from the internet, which is located in the outside zone, to be able to connect to our public web servers in the DMZ? And if what you say is true, connections initiated from a lower level zone to a higher level zone would be denied by the firewall by default. And you know what? You are absolutely correct. To override the default behavior of security zones, we would need to apply an access list or ACL. With the ACL, we can tell the firewall to allow connections from hosts in the outside zone to our certwiz.com public server located in the DMZ off of port 80. ACLs, or access lists, are the way to override the default behaviors of security zones. Another example, we have Bob in accounting who loves to visit peer-to-peer and other weird sites in his spare time. His computer is located in the inside zone, so by default he can access anything. With the access list, we can deny Bob's computer access to anything destined for, let's say, port 80, which is used for HTTP traffic, overriding the default behavior of the inside security zone. Now, before we end this video, there are a few more features I want to talk about, or at least mention, but I won't go into too much detail because they border on the lines of CCNA security, but you guys should at least know what they are. Firewalls can also do network address translation or port address translation, in other words, NAT and PAT. Since private IP addresses are not routable outside of the local area network, the NAT and PAT features can mask a private IP address with a public routable IP. And the last feature is VPN, or virtual private networks, which allows users out on the internet the ability to connect to a company's inside or internal network. Alright guys, this concludes part 1 of our discussion. I will see you in the next video.